This is a tutorial video aimed at GCSE chemistry students in which we examine how to calculate the number of subatomic particles in an atom of any element. There are about 100 elements, and these are listed in a document called the periodic table of elements. The smallest part of an element that can exist is something called an atom, and each element has a slightly different atom. One thing it's important to remember is that an element is defined by all of its atoms having the same number of protons. You've probably already met this model of the atom, which is sometimes referred to as the modern model or the Bohr model. It's made up of 3 subatomic particles, in other words, particles that are smaller than an atom. These particles are called protons, neutrons, and electrons. And there are different numbers of these subatomic particles in the atoms of the different elements. We can calculate the numbers of these different subatomic particles by looking at a periodic table square, like this square for lithium. The first thing we need to look at is the atomic number. If you're studying for the AQA GCSE Chemistry or GCSE Combined Science exams, then this is referred to on the key for the periodic table, which you do get in the exam, as the atomic brackets proton number. So instantly we know that lithium has 3 protons. That's very important. Every element in the periodic table has a different number of protons. So regardless of anything else, a particle containing 3 protons is always lithium. Next, we can say that in an atom, the number of protons is equal to the number of electrons. At this point in the GCSE course, you probably haven't met any particles other than atoms. But it's just worth highlighting that this rule about protons and electrons being equal isn't universally true. It's only true if we're talking about an atom. So since we have 3 positive protons in our atom, we must also have 3 negative electrons to balance out the charge and leave an atom that's neutral overall. Working out the number of neutrons is slightly more complicated. The other number on this periodic table square is called the mass number. You might have seen it referred to elsewhere as the relative atomic mass. To cut a very long story short, some elements have more than one possible version of the atom, called isotopes, although all of those isotopes will still have the same number of protons. And the relative atomic mass is the average mass of those isotopes. So anyway, the mass number tells us how heavy the nucleus is. It's the combined number of protons and neutrons. So if we already know how many protons there are, by subtracting this from the mass, we get the number of neutrons. And in this instance, this is going to be 4. Let's look at some more examples. Beryllium has an atomic number of 4, so immediately we can say that it contains 4 protons. In an atom, the number of protons and electrons is the same, so therefore an atom of beryllium will have 4 electrons. Then, to work out the number of neutrons, I need to use both of the numbers on the periodic table square. So I'm going to do 9, which is the mass, subtract 4, which is the atomic number, to give me a total of 5 neutrons. Aluminium has an atomic number of 13, so therefore it must contain 13 protons. Since the number of protons and electrons in an atom is the same, an atom of aluminium must also contain 13 electrons. And then to work out the number of neutrons, I'm going to do 27 subtract 13 to give me 14 neutrons. Here's a final example. Pause the video and write down what you think the number of the different subatomic particles is to check that you've got this right. So hopefully you've realised that with an atomic number of 22, titanium must have 22 protons. Protons and electrons are going to be the same as each other, so therefore there are 22 electrons. And the number of neutrons is going to be 48 minus 22, which is 26. Thanks very much for watching, and I hope you're now feeling really confident in calculating the number of the different subatomic particles in an atom. If you did find this video useful, then don't forget to like and subscribe for more GCSE chemistry videos coming soon.